Welcome to our program of learning algebra. In our last program, we invited a parent and a teacher, as you must have seen. And we got the feedback from them as to what they think about challenges in teaching algebra to kids. And I hope this kind of session was very helpful. We'll be inviting in our future sessions more of parents and teachers like this, so that this program is not just me talking on the camera, it's also a lot of interaction from you all. Well, welcome back. In our last program, we talked about balance, algebra balance. Algebra is all about balance. So what did we see? We talk about an example. We took an example of seesaw, and we saw how if we put weight on one side of seesaw, it gets tilted on that side, and then when we put weight on other side of seesaw, it gets tilted on other side. But solving algebraic equation is all about making seesaw balanced. I got some feedbacks from our viewers that this example of balance, example of seesaw, was little faster, and so on your request, on viewers' request, what we are doing is we are doing some more exploration into balancing. So in our current program, we'll be talking more and more about balancing. We'll take some more examples about balancing. But before we move forward, let's see. I wanted to tell you something about our program. The good news, first of all, we are live on internet. We have a website, and the website name is growalgebra.com. So you can go to your computers, you can open your browsers, type www.growalgebra.com, and as always, you have my email address. You can send me emails for any questions, comments, and for the quizzes also. I would like to take a few seconds to explain or to walk through about our website, growalgebra.com. You'll see our telecast date. At the beginning of each program, we have telecast date, the date on which the program was telecasted. And then we have on this section our archives section, which talks about our previous archives. If you want to go back to our previous shows and have a look, you can go to this section. Then we have another section which talks about video movie. You can play the video movie, and if you click on one of the archives, and let's say you want to go to January 17th archive, you click on that, you will see a video movie, and click the play button, you will be able to watch our program which was telecasted on January 17th. Let's see. Then we have topics. We have organized our whole website so that it's easy for viewers to understand. Now we have topics covered, so under each video we are also telling what are the topics we are covering. For example, in one of the sessions we talked about numbers and rational numbers, absolute value of number. So those summary of topics will be written in this section. And the last section is the comment section. Comment section is very important for us. It's not only for quizzes, answers, it's also about how we are doing, how you feel about this program. I've got some comments so far, but I think this was a part which was not really highly visible. So we have made this part now very explicitly visible. You can feel free to put your comments on this section. Well, welcome back to our program. Let's see the roadmap. The roadmap where we have been traveling, how far we have gone in the process of learning algebra. So before even I talk about balance again, let's talk about what are the things which we have learned so far, so that it should not happen that we are learning new things and then we are forgetting old things, right? That will be bad. And again, as I mentioned in our previous classes also, algebra is all about practice, practice, practice. You have to practice, and who will help you? Who will help you to understand the concepts of algebra? Let's see what are the things which we have learned so far. Numbers. We have learned numbers, and the first example, you remember this slide where we talked about integers, we talked about rational numbers, we talked about irrational numbers, we talked about infinity sign. Anything which is x divided by y, where x and y both are integers, are called rational numbers. Anything which cannot be represented by x divided by y is called irrational numbers. We have integers, we have whole numbers, we have positive numbers, we have negative numbers, we have our zero, we have our infinite, we have minus infinite. So this is all about our number systems. After number system comes our impact of the sign. You remember this part of the animation where we said you multiply plus 4 with minus 1, it becomes minus 4. You multiply minus 1 with minus 4, it becomes plus 4. So minus is a flipper. Minus, whenever applied to a number, it changes the meaning of the number. It flips the number. So if you have plus 4, it becomes minus 4. If you have minus 4, it becomes plus 4. Alright, we also saw absolute value of a number. As an example, the example which we took was, let's say if we have two cars, one car moving at 100 miles per hour in one direction, let's say from left to right direction, and we have second car which is moving at 30 miles per hour in other direction, let's say from right direction to the left direction. Now these two cars are moving at different speeds. How do we know which car is moving faster? And you remember this example, our favorite animation? One car went very fast, the other car is still moving, still moving. Now this is the practical usage of absolute value of a number, and we'll be talking about more examples as we move forward. These terms we will be using a lot. We also talked about prime numbers, even numbers, odd numbers. Prime numbers were the number which are not divisible by any integers and give you a resultant as another integer. Just as an example, number 11. Number 11 is a prime number. You cannot divide number 11 by any integer and in the result get another integer. Then we talked about even numbers. Even numbers are the numbers which have 2, 4, 6, 8 or 0 as the end. Odd numbers are the numbers which have 1, 3, 5, 7, 9 as the last digits. So this was all about numbers we talked about. Now the next thing is balance. We talked about the golden rule. It's all about balance. It's all about balance, and again we will take some more examples. We'll talk in more detail as to what we mean by balance, what we mean by our golden rule. So talking about balance, it's all about balance. When we are talking about solving an algebraic equation, it is about making sure that left hand side equals right hand side of balance. Alright, this time we have a different balance. This is a three-dimensional view or a version of a seesaw. On the left hand side, we have marked two sides of the seesaw as left and right, so that this time it's much more easier to give a reference point. So if I say left one goes down, so you all know which one I'm talking about, and if I say right one goes down, then you know which one I'm talking about. Now before even exploring into how we solve algebra using seesaw, let's look at the properties of this balance. If you put a force, if you put some weight on the left hand side, the left side of the seesaw goes down. Now if you put some force on the right hand side, then the right side of seesaw goes down. And at any point, if we have an equal amount of force on both sides of balance or both sides of seesaw, then we see both the sides are balanced, they are on level. You can see that in this picture that none of the sides is tilted, neither left side nor right side. So in this situation we are calling our seesaw is balanced, we are calling our balance is balanced. So we call our algebraic equation is balanced or solved, and we'll be talking more with examples in our coming slides. Alright, let's take an example. We have our three-dimensional balance or three-dimensional seesaw here. On the left hand side we have some cubes. These cubes represent object. We do not know what is the weight for each object. Now the challenge is that we have to measure the weight for each object. On the right hand side we have got certain weights, and assuming the weight for each object is 1 unit, it could be 1 gram, it could be 1 kilogram, whatever unit you're all familiar with. Assume the right hand side brown cylindrical objects have weight of 1 unit. That's why I'm using the word unit, not a gram or kilogram. Let's see what happens if we put the cube, the unknown object, on the left hand side of the balance. Alright, as soon as we do that, the seesaw gets tilted. You remember our force example which we talked about? As soon as we put force, as soon as we put weight on one side of seesaw, it gets unbalanced. The balance is disturbed. So our seesaw is going down in left direction. It is tilted towards left direction. And you must have noticed that I've put N on the left hand side. which tells that we do not know the weight of cube. So anything which we do not know is, in our algebraic word, we are representing that with any alphabetical symbol. We could be using X, we could be using A, we could be using N. Now, to keep it dynamic, to keep the fundamentals of algebra clear, we are changing these symbols every time. So this time I'm using N. In our last slides we used X. So now I'm using N. Alright. Let's also add some more challenge to it. Let's add one more unit of our known weights to the left hand side. Now what happened here is we added 1 to N. Now on left hand side we have N plus 1 weight. What should happen? Our seesaw should move a little more towards left, right? Yeah, that's what has happened. Now this is our challenge. With all the objects, we have cubes, we have some known cylinders, cylindrical object. We have to identify what is the weight of a cube. We have to solve for N. Now the way we will solve it, we are taking a practical approach here. We will try to put some objects on the right side of the balance and see at what point the whole seesaw becomes balanced. The whole equation becomes balanced. That's our objective here. So let's see here. We have put one object, 2, 3. Alright, as soon as we did put 3 objects, our seesaw got balanced. So on the right hand side I have put number 3, and in the middle you must have noticed I have put a equal sign. Now what does it mean? It means N plus 1 equals 3 in our algebraic word. See, this is our algebraic equation. And what's happening here is we have an unknown object, we have a known object on one side, N plus 1, and we have 3 known objects, 1, 2 and 3. So basically 3 units of weight on the right hand side, and these 2 sides are now equal. How do we solve for N? Or in other words, how do we find out the weight for weight of cube? So just wanted to represent that in our algebraic word, N plus 1 equals 3. This is our algebraic notation. So our challenge is how to get the value of N. Now answer is simple. We have to subtract 1 unit from left hand side. As soon as we subtract 1 unit from left hand side, we will have only 1 cube left on left hand side. So basically now we are solving for 1 cube only at that time. Let's do that. Alright, we did that. But what happened here? As soon as we took off 1 unit, our balance is now no more balanced. It got unbalanced. So we need to balance it. We need to find out what should we do so that our balance should be balanced and we should be able to solve our algebraic equation. And it is the time to put our golden rule. Perform same operation on both sides. You remember our golden rule? Our golden rule said whatever operation you are putting on one side of balance, you have to perform the same operation on the second side. So what we did here, we did subtract 1 unit from left hand side. Now we have to do the same thing. We have to subtract 1 unit from the right hand side. Let's see how it works. Alright, we subtracted 1 unit from right hand side. Congratulations, our balance is now balanced, or our seesaw is now balanced. What you are seeing here is n plus 1 minus 1. So we had 1 cube and then 1 unit of object originally, excuse me, and then we took out 1 object, so n plus 1 minus 1, and on the right hand side we had 3 objects and then we took out 1 object, so 3 minus 1, which is equal to n equals 2. See how we solved our equation for n. So this is how we can correlate our real life word with algebra. So just take a look how and what we did, and in our next slides we'll be explaining in algebraic word what we have done. Alright, now it's time to solve this equation in our algebraic word. We had n plus 1 equals 3. And in order to solve for n, we had to subtract 1 from n plus 1. So n plus 1 minus 1, and we had to do the same operation on the right hand side also, equals 3 minus 1. Alright, means n equals 3 minus 1 equals 2. So do you also see something? We are deriving our second rule, second golden rule of algebra out of it, that numbers change the sign when they change the sides. You remember in our third class we talked about the numbers changing their sign, and I promised you that we will be talking in more detail as to why it happens when numbers change the side, the signs are changed. And this is the practical example, this is the practical explanation as to why numbers sign change when they change the side. So if a number was positive on the left hand side, as soon as it changes the sign it becomes negative. If the number was negative on one side, it becomes positive. And we'll also see what happens if we have more signs, because we can have a multiplication sign, we can have a divide by sign. So what happens and how it happens, we will be talking about that in our next slides. Alright, let's see here. We are trying to get a little more innovative here and explain you about this whole balance concept. What we did in our previous example, we added weights on both sides of balance and then tried to solve it. Now we are trying to add different objects, and this time what we are doing is we are taking balloons, the balloons which flow in the air, and assume each balloon has a force of 1 unit to move object up. So you remember that thing? The magnitude. The magnitude we talked about in our previous examples, and we also promised that we will be talking about magnitude in different contexts also. So here is a different context. If weight moves balance down by 1 unit and balloon is moving up seesaw by 1 unit, so which one is heavier or which one is more powerful? Well, both of them are equal, but it is just that the direction of forces from both the objects is different. So we talk about magnitude here. Alright, let's see the behavior of putting balloon with seesaw. We take out one balloon and we link that with our seesaw on left hand side. What should happen? Well, when we get a thing tied to balloon, the things move up. So left hand side of the balloon will move up. Here we go. The red arrow shows the direction of force, and our seesaw moved in upper direction from left side. So right hand side actually moved down. So this was the impact of putting a balloon on seesaw. So it's also, in our algebraic terms, we can say we are subtracting a number. When we put a weight, then we are correlating that with adding a number, and if we are putting a balloon, then that means we are subtracting a number. Alright, so what we are doing here is we are also putting object here, and as we put an object, we are putting one more force but in the opposite direction. See, these two forces were equal in the magnitude but in opposite direction. What happened here? It did made the seesaw in balance. So we subtracted one, we added one, and our seesaw is now balanced. So we will use this example, we will use in our next slide how we can derive more equations which involve minus and plus signs, and then try to solve them. And we'll be seeing you in our next class. That will be solving in our next class. Thank you.